नमस्कार मैडम।
हाँ जी। हाँ
मैम
कहाँ हो?
मैं तो अभी बाउंड्री वॉल के पास हूँ।
क्या करवा रहा है बाउंड्री वॉल को?
वो आपने तो पता है ना, फ्लैग उधर डालने के लिए उसको बाउंड्री वॉल तोड़ना है।
अच्छा उधर है, उधर है। ओके।
क्या हो मैडम, अभी कहाँ है आप?
मैं तो
ऊपर है,
इधर
नीचे?
ऊपर आई थी, वहाँ पे तो विवेक सिन्हा के नाम के ऊपर बोर्ड लगा हुआ है, हेड सीपीयू।
विवेक
Hello, madam. Ranju, madam, we can hear you. Please
वो है
mute
ना, वो
your
ठीक
mic.
है, तो उनको दे देना।
Good afternoon and welcome all for this sixth lecture of series of lectures by eminent scientists. And today we have with us Professor O.P. Sharma. He is professor, retired professor in Center for Atmospheric Sciences, IIT New Delhi, and guru of many of our officers in IMD, IITM, NCMRWF. We welcome sir for this lecture, and at the very outset I would request our Director General to kindly deliver a welcome note for today's speaker. Yes. Oh. Yeah.
Good afternoon, namaskar to all of you. Respected Professor O.P. Sharma, the chief guest of this afternoon. My dear friends and colleagues joining physically and online to this lecture series to commemorate 150 years of India Meteorological Department. When I say it is the 150 years of an organization like IMD, it tells about the story of the growth of meteorology in the country. It is not limited to IMD, but the entire meteorological fraternity of the country. As all of us know, starting with that British era, there has been many milestones over the years wrought by the country, bringing out various types of services to the people, not only in India, but also in the world. There has been a leadership in the field of science of meteorology and allied sciences, and accordingly, the science to services, which has led to minimization of loss of lives due to various types of natural hazards, and also it has helped individually to minimize the loss of properties. Behind this development, there has been different pillars leading to this success story. It includes the development in observational network, the modeling systems, computing systems, forecasting process, early warning generations and disseminations. On the other hand, there has been a lot of activities to improve the information on the climate, starting with the basic climate products generation, climate informations, then the climate monitoring, the climate predictions, and at present we go for the climate services to various sectors, specifically towards the DRR, the disaster risk reductions, hydrology, health, energy, and many more. So while carrying out all these things, all these pillars, there is another important pillar which has contributed to the growth of meteorology in the country, that is the research and development in all the fields, be it the observational capacity, or be it the modeling capacity, or the forecast and warning process. The research and development has contributed significantly to improve our quality, to improve our knowledge base, to improve our service delivery. And while we talk of this research and development, there has been some seminal contributions in an organized manner by certain institutes. And the first and foremost which comes to our mind is the joint initiative taken off in 1970s by the Indian Institute of Technology, Delhi, and India Meteorological Department. And from that time onwards, there have been many stalwarts who have contributed throughout their life towards this collaboration and hence improvement of the science of meteorology and its applications. Professor O.P. Sharma, who has been teacher to many people in this field of meteorology in the country, who worked as a professor in IIT Delhi, has its root from those days in 1970s, while we talk of the development of research institutions to support the operational agencies like India Meteorological Department. He has been associated with many research projects and experiments. When we talk about the MONEX 1979, when we talk about the other experiments, he is the person who has been involved with IMD and with many other agencies in the country to take off the new challenges. And all of us know that monsoon and cyclones are the most important challenges in the country like India. And therefore, his contribution towards this monsoon research and other severe weather research has tremendously helped the organizations and the individuals. We are really very happy, sir, with your presence today and for your kind consent to deliver this popular lecture on the backdrop of 150 years of India Meteorological Department. We will be completing 150 years on 15 January 2025, and curtain raiser started on 15 January 2024. There are many activities which are being taken up, but this lecture series, which is being delivered by the eminent personalities, are certainly the golden opportunities for the youngsters, the young scientists, engineers, practitioners, the operational forecasters, who can learn a lot to build up their career, who can learn a lot to contribute to the organizations for improvement of the services, and who can be the global leaders. Taking the examples of these laureates who are delivering these lectures. All of us know Professor O.P. Sharma, but however, we will have the brief introduction about Sharma sir. But I want to mention here to our youngsters to take this opportunity to learn maximum about this field, his contributions, and how the collaboration becomes the key to success for any kind of endeavor. When you talk of the national collaborations, it is the IIT Delhi which started first. But similarly, when you go for the international collaborations, there are many countries who have collaborated with IMD in the beginning era. And he will talk about that. I will not talk about this. But on behalf of all of you, on my personal behalf, I express my deep gratitude to Professor O.P. Sharma for agreeing to our proposal to deliver this talk. Thank you very much.
So request Anup to make a formal introduction of today's speaker, Professor O.P. Sharma ji.
Thank you very much, sir. And a very good afternoon and namaskar to all of you. I'm Dr. Anup Misra from DGM office, IMD, New Delhi. I'm privileged to get an opportunity to introduce our speaker. We have Professor O.P. Sharma, who will be delivering a lecture on collaboration of IIT and IMD on monsoon research. Professor Sharma completed his doctoral degree from IIT Bombay in 1975. And of course, after completing his school and college education in Rajasthan, and he was mentored by Professor M.P. Singh from IIT Delhi and Professor P.K. Das from IMD and IIT Delhi, who encouraged and guided him to work on modeling problems in meteorology. Professor Sharma worked at IIT Delhi in various capacities from lecturer to head and professor for 38 years. And the field of specialization of Professor Sharma are monsoon modeling, ocean and atmospheric circulation modeling, atmospheric chemistry and aerosols, computation, fluid dynamics, and methods of applied mathematics, finite elements and finite differences. The pioneering work of Professor Sharma is in global atmospheric modeling, where he worked on Stuttgart global model, the monsoon general circulation model, under the guidance of Professor R. Sadorni at LMD Paris. and he was a key member of a few scientific and advisory committees, notably a member Scientific Advisory Committee of SAC, National Atmospheric Research Laboratory, and Indian Space Research Organization ISRO during 2008 to 2015, and member Program Advisory Committee on Atmospheric Science, Department of Science and Technology during 1991 to 1998, and member Technical Consultative Committee for Supercomputer, Department of Science and Technology during 1989 to 1993, member Indian Delegation of Benchmarking of Supercomputers to USA and Japan, and he has supervised 20 doctoral students for their PhD degree by IIT Delhi, and 21 students completed their thesis projects for the award of MTech, MSc, and BTech degree. He also carried out various sponsored research funded by IMD, DST, CSIR, MoES, ISRO, and Government of France. He has published 64 journal papers and presented 20 papers in conferences and workshops. After retirement, Professor Sharma started taking keen interest in music, long distance running, and children's education. He enjoys trail running and marathons. So kindly join me in welcoming Professor O.P. Sharma.
So now I would request Professor O.P. Sharma to kindly deliver today's lecture.
Sir, with your permission, I can speak.
Yes. Whether you want to go there?
Yeah, I will.
PPT. There is no
No,
PPT.
I don't have PPT, but
Okay.
I will.
Then you can speak here. You can speak
Yeah,
here.
but if there are certain pictures, then I
Okay,
can.
okay, okay.
BGM, sir.
ऑन कर दीजिए माइक।
Speak to that microphone online.
So,
please.
no, it's okay. Thanks. So I first start that this room is very precious to me, and as I was telling the that where the lecture will be, then he told me in a room just opposite to DG sir. So you won't believe that in this seminar hall, Professor P.K. Das, he was the Director General, and we had a conference in 79. So that was the Indo-France conference, and he invited all the participants. So this room was packed. These were very small that time, and I was sitting in that corner with my supervisor, of course, sitting in the front. So the discussion was on monsoon research, and how that all started. We came to that brainstorming session. The story began actually with the Indo-French Center, Indo-French cooperation of IIT Delhi with France. So the top mathematician that time in France was Professor J.L. Lyons, and his student and MP Singh, they shared the office in Cambridge for a year. And then they both started talking, and Professor Pirano, who was my co-supervisor in France, he had a lot of interest in Aurobindo. So he was highly impressed by the Indian culture, and also to say, French people have those kind of things. So what I say that there is a mutual kind of, liking, it starts automatically. So they said we should have a lot of programs. And so Professor J. Lyons, he said, you come to France and identify institutes. So he identified for me LMD, and for my one colleague, Professor Jaraman, a medical university in the hospital Henri Mondo. So before that, means we should have some topics, right? Without topics, if we go to France, what's the use? So the program was on application of mathematics in the Department of Mathematics at IIT Delhi and the Informatic Institute in France. So Professor Singh, he was looking around, and he came to know about Professor P.K. Das, and he visited him several times. And Professor P.K. Das got so excited that there is some people who are there to work on monsoons. The reason was he was the single soul. So if Koteshwaram Sahab, if you ask, he's no more, but if you would have asked Koteshwaram, oh, NWP, that is Professor Das, that is Dr. Das. So he was very happy that he can talk to some people. So in 75, we started coming here, and that time, YP Rao sir, the director there, observatories, they were called observatories. So we used to come, Professor Singh used to take me along, and we used to come. So the story started from there. So Professor Das, he chose a problem for me, that of vertical motion in the atmosphere. And he also said, okay, Somali current also you should simulate if there is a, so you have two problems. If you work in ocean, you will work on Somali current. If you work in atmosphere, you will work on the vertical velocity in atmosphere. So I go to LMD and I meet Professor Sadoni, because the director told, okay, Sharma, you will meet Sadoni, and he will be discussing with you. So when I knew about Sadoni, I was from mathematics, no knowledge of meteorology. In fact, there was one Chabra Sahab, very wonderful person. So he asked me, Sharma, यार तेरे को subsidence तो आता होगा? मैंने कहा जी आज ही नाम सुना है. So it was like that. So anyway, so when I knew that he has written the first grid point model of ECMWF. So I said, who can be the best guide for me other than Professor Saloni? So I said, I won't work in ocean, I'll work only in atmosphere. So this is how it started. And that vertical velocity equation, you know, it's an elliptic equation, and for the finite elements. Professor Das told me, you will work on finite elements, as Professor Singh was insisting. So he was repeating the same thing. You can see how things happen. So I started learning finite element, and very quickly in 4 months time, I could finish my that problem. Then Pirano told Sadoni, you know, he's a young fellow, that problem he has solved, because I'll teach him finite elements, which I learned. In one, I don't need to prepare anything. It just comes automatically, because you have worked it with hands. So he said, if you are ready to work with me, then we can work on a very ambitious problem. So he imagined a new general circulation model, and I started working. So many of the reminiscences I have put here just as an introduction, which you can read. But I am here only to talk about the excitement which I had experienced in IMD, interacting first with Professor P.K. Das. So the thing is, Professor P.K. Das, he became the Director General. The interesting story is this, you should all know, Vijay sir, so he knows it. So, but he used to talk to me and tell many things to me. So he became Director General. Then the story was Mrs. Indira Gandhi, who was very keen. She is one person I have so much of respect and regard. She was for the poor people, and many instances are there. So she said, why this monsoon is a scientific problem, and I hear. So she, out of mind, she just told Krishna Rao Sai, was the cabinet secretary, oh, call Mr. Das to meet me. So, you know, Prime Minister gives only a slot of 5 minutes. Rather, Prime Minister doesn't give. Krishna Rao Sai used to give only 5 minutes of time. So as Professor Das used to tell me on a cup of coffee or tea, he used to like tea without sugar. So when Krishna Rao Sahab called his office, Das Sharma Sahab was here. So he conveyed that such and connect. So he is invited, and then that letter comes. So that time IMD was under the civil aviation. So it will come through the civil aviation, the invitation. So there was a secretary, his name I still remember, his name was Venkatraman. And his PA was also a Das. So that Das used to call, because Venkatraman must have told how PK Das got a direct, he should have been called through him because he's the secretary. I'm telling you because this is an interesting story. I cannot put in these words here. So he used to say, so that one day comes the PK Das, because he was highly embraced by such questions. So he says, you, Mr. Venkatraman, you please tell Mr. to the PA, he said, tell Mr. Venkatraman to ask Mr. Krishna Rao Sahib. After that, he did not get any call from him, but he went to meet Mrs. Gandhi. So Krishna Rao Sahib was very authentic person. He said, Mr. Das, you are here? Yes. You have 5 minutes, okay? And whatever your problem, tell to Prime Minister. He enters and 5 minutes, Mrs. Gandhi, Mr. Das, tell me how I can help you. And then Dr. Das, with a lot of hesitation, because there was practically nothing except the balloons which they used to put, or the meteorologist, whatever by his mind he can think, or what are the observation he has to put on the chart. So he very defensively he said, ma'am, what can I do? I have best people, but they have no means. And then he started telling about all these things. Miss, at the best, what I can do only with precipitation. इस साल ये precipitation हुआ, मैंने ये किया. Based on that, whatever the inference we make, we have been able to do that. And something like that, he said. So the story continued for half an hour, and he had only 5 minutes. And Mrs. Gandhi, who was occupied, so there were several meetings behind. Rao Sahib said, no, Mr. Das is discussing with us, you have to wait, you have to wait. So the point is that monsoon was actually is that kind of problem. If you start discussing the problems, you can spend hours and hours. And I tell you, here, why this was possible? Because if you go back in 90s, 20s, Gilbert Walker Fulton, before that, the director generals, they, from nowhere, out of the thin layer of data, whatever they have, maybe temperature, maybe pressure, they propounded such like, Haley said, oh, monsoon can only happen because of the grass. This was a law. Hadley says, no, there can be something more. There is a one cell which goes like this, equatorial heat goes down, comes back, and then, okay, convergence of trades, etc. He defined very well. Now, the point is that kind of tradition which was set by Walker, and later I have put a lot of things on Dr. Sudhanshu Kumar Banerjee. I have so much of respect for his mathematics. He was a thorough, and he was the Director General of Observatories after the English era. In the English era, from the English person, he took that charge. He took a problem that is the barriers, monsoon barriers. And I have given you if you look at the picture, I have given the first principle. The first principle, that is the on the page 2. First principle, this is called the continuity equation. Normally, if you say, yeah, this is the continuity equation, and these are the streamlines not from the data. He actually imagined he actually imagined that this function is something like this. If you look to his paper, and you can see even the trough is visible there. Even little trough is visible there. And what he said, that once they come here, they deflect, and there is a trough formation like this. Of course, the kind of thing which he was telling, the kind of vertical velocity he was talking about is, so he was a very wonderful fluid dynamicist. So what happens, we know how from the conservation of potential vorticity, the moment there is a stretching of the vortex, positive vorticity develops, and So relative vorticity increases. So Earth vorticity is fixed. So when it has to conserve its vorticity, so it has to drift southward because lower Earth vorticity, background vorticity needs to conserve that way. We now know but imagine that he said this is a mathematical solution of this equation which is of this form. Can you believe this? We have very few examples in science and mathematics when a person thinks that, yeah, people have done one thing, but here it is two-dimensional example of theoretical. So I have idealized mountain barrier with theoretical streamlines. So it's not any something like that. So such brains, they were part of the IMD. So if you do this simple imagination, this UG by 12, so this is the air which is going up. It means the vertical velocity is nothing but UG by 12. If you take this UG as 10 meter, which is very usual, we assume in the large scale. So this is something like 80 centimeter. If you have a release of latent heat, still there is a buoyancy, and that buoyancy will further boost the vertical velocity, and you have tremendous development of the convective. All these things are so nicely described in this paper. So I have taken example. So this actually set the tradition, whether in IMD people were working on data. Besides that, the mathematics behind those developments was very clear to people, and there were equations with rotation and all that. So as I told that Professor P.K. Das, he was already there. So Professor P.K. Das and M.P. Singh, they joined. And in 79, when the conference was there, the Patnaik sir was the minister. I have forgot. So Dr. Das became DGM. So he came with him to IIT, and we had the conference. And at that conference, we had my entire lifetime, research points were put, and there was a need for the variable grid resolution model because you have this number of points same, just for very limited memory, limited speed of computation. Can you believe the supercomputer used to have 1 MB of memory? जिसको RAM जिसको कहते हैं, that was 1 MB. And in France, which I was using, they used to call supercomputer was 2 MB. So he's laughing, but that was the kind of thing. So our idea was, Professor Singh's idea and Professor Das' idea is that, why don't we join hands? So if the center is the group, so it was a group in maths department, he encouraged my friend, ever my good friend, Shishir Dubey, that you have done fresh PhD, you have done the training school also, why don't you join IIT? He never thought, okay, IIT, he just resigned and he joined our IIT. So another person came to our group, and a year later, UC Mohanty sir, wo jo hai, he came after submitting his PhD from Russia. So Dr. Das told, you want to join IIT? Yes, I can join IIT. So he joined IIT, taking leave from IMD. So that's how the group started. Then we 3 people were working on one was in diagnostic studies, I was in modeling, and Dubey Saab on storm cells. So we had 3 pillars. So Professor P.K. Das and M.P. Singh, they said we have 3 thrust areas. One is meteorology, another is oceanography, and third is air pollution, right? So meteorology is a huge subject, so Professor Manti and we were put on that. And for ocean, Dubey Saab was there. So Dubey Saab immediately took a student. His name is, now he's a very big name and very popular name in storm cells, Professor A.G. Rao. So he immediately got him registered, and he finished his PhD at a fastest rate possible, you can imagine. So he was taken into faculty, and the thing started like this. So my point is that monsoon research starts with the meeting of minds and something which you imagine. The imagination is very important. So when we say that I'm interested, that doesn't work. The two should be interested. The person whom you are talking, and yes, you can be interested always, but the other person should also be interested. Actually, for me, it happened like that. In France also, my mentor and my guide, Professor Adorni, absolutely, he will come and say. So the story of variable grid is very different. Once we had this idea, so I was working on a different model, which was with the mean state and then calculating the perturbations, and then adding and then producing the entire forecast. There was some problem because the tropopause came about a kilometer down or two, which we wrote the full paper except that defect. Everything was okay. So Dr. Sadoni told me, Sharma, there is a problem, the tropopause is down. I said, then forget it. So we were writing a paper for the TELUS. He abandoned it. He says, now start the variable grid because I have already given the assurance to this thing. So mathematically, it's a very wonderful technique. It's the stretching of the coordinate. So stretching of the coordinate and the fixed point theorem we apply, then we can systematically produce the variable grids. And if you look at the variable grids on the second, if you turn the page, and you can clearly see the variable grid in the dots on the. This is the. Can you move? Just 1 second. This is the conference on monsoon dynamics in '77, when we had Professor Lighthill from Cambridge. We also helped the formation of the center. That was. He is our director. Vajpayee came for the inauguration, and he is Dr. Dharmveera, who was our board of directors, and he is Professor M.P. Singh, who is just discussing that. So this was a very. I took this picture, and there is so much of warmth in here. You know, they are all laughing. Actually, can you believe that? In conference, everybody comes, and then they are all laughing, and even Lighthill was closing his eyes, and he's remembering because he has to give a lecture immediately. So there is a lot of feeling here, and you can see that I wrote my first paper also on vertical velocity with Mr. M.C. Sinha. He was also from IMD. So you can believe that my first paper and my first problem came from IMD, and DC sir has given me the opportunity to talk today in IMD. What can be a bigger pleasure than this? You can sense my happiness. So the thing is that all these things I have put. So next can you go? So this is that picture I already talked about. Tikeda Sahib here and Patnaik Sahib is there, and they are coming for. Okay, can anybody identify, sir? He's no, Sona safe, Sona. Please, Sendroy sir. Sendroy sir. JB Patnaik. No, he is JB Patnaik. Yes, Sendroy sir है पीछे. So Soma's father, he also came that time. So Professor P.K. Das, and at this conference. I was sitting there and everything was planned in this room in a brainstorming session. So that was the story. Can you go up, please? So this is the picture I am talking. If you look at this, actually this is not that I have put one by one. It's through a function, right? Through a function. So basically you can have on one side regular points, and on the other side you can have the point. You just draw the vertical. Wherever you have dots, that is the function you take. So I took a sine function which has zoom here, the rising motion, the rising curve, and then if you put so all this one function, and for every latitude you do that. So you will get this picture. So this is by an analytical function. So such choice of points doesn't give error in the discretization. All these things are important, and you can see that the same model, but without this grid, regular grid, means all points are at the same distance. This is the FGGE data, means MONEX data of 11th June, and there was 14 June. There was a onset. So regular model actually predicts the rainfall here, whereas the simple small, the stress grid model, of course, the development is huge. It took me 3 years to complete that. And the story is that Professor Sadoni sat with me only 3.5 hours. 1.5 hour one day and another day 2 hours. That's all. So in 3.5 hours, and I took almost 3 years to complete the entire coding. And we created beautiful mathematics in horizontal diffusion. We created beautiful mathematics in Fourier filtering. So it is not fast Fourier transform which we use here. It is actually beyond, we have a truncation number, and above that we do the filtering. So we save a lot of time. So the only we filter the points over the fine area. Rest is all automatically. So this rainfall I'm showing because this rainfall is very sensitive in the model. So this was our first kind of success which Sadoni presented. Can you move up? Move down. So this he presented it at the in the seminar in Florida State University, and Dr. Krishnamurthy, he became very happy. So in fact, Professor Krishnamurthy became a very good friend of mine after this. Oh, you do this thing. So these were, and finally I visited him in 1986 for 6 months under the STI program. So again, to come to the story that when Dr. P.K. Das spoke about his difficulty in the IMD, Mrs. Gandhi used to tell in that half an hour, Mr. Das, if you ask me, I can give a personal guarantee. She talked like this: personal guarantee to Mr. Reagan, and the supercomputer will come exclusively for this thing. So that's a word actually, but a word spoken by a leader of that actually becomes a huge activity. So when the STI program, in which IMD played the key role under the DST, and health, the two fields they chose, and under that, the moment it came, IMD first said we want a supercomputer. In that also, because some of the people in US, they used to say, oh, India can work with a regional model. But since I was working in a global model, I already designed that kind of model. So Professor Das, he said, nothing doing. A single soul is working on that, and you are saying only regional model for IMD. This is not acceptable. So overnight, when Dr. Dilal, the meeting happened in the Indian team, they met in Ahmedabad, and I was called that you present what you are doing. And I did that in small. So Dr. Dilal also became my wonderful friend there. So the thing is, the moment and Dr. Das was very angry. Why don't you accept my point? Here is a person who is doing it. So overnight, the philosophy changed, and Professor Pissing, who was also a member of that committee, he came and told me, you did a very good thing. Fearlessly, you said everything, and fearlessly we put our point. So IMD will have a major say in this thing. So the under STI, entire IMD people could, there's a lot of them. They visited NCEP and other universities, beat satellite, best places. So the things become that strong because the leadership is strong, then the people are there to work on it, and the story continues to evolve like that. So then once we had this thing, I mostly was working on the development of models. So our program started like this. We were working. Then at the same time in 1980, Professor P.K. Das had the opportunity, because you go to the planning commission for funds and you make a presentation. There also, means it was a time when during the regime, during the time when Professor P.K. Das was here, his one friend who was his classmate in Doon. So Navraj Kumar, I remember very well because he was friend to my wife's brother. So Navraj Kumar was his classmate. So he presented, and he said, you always support IMD, but you don't support the activities which feed to IMD. So he got a very good message. He says, okay, tell us clearly. He said that at least there should be 2 centers uh, which are dedicated for the or three centers in scope actually. One in Calcutta, one in Bangalore, one in Delhi. You should have at least 3 centers where exclusive meteorological work on modeling and other things that goes on. So planning commission in its own wisdom, they say, okay, we grant 2. So Professor Narasimha was asked, submit the proposal, and we were already ready with our proposal because you see Mohanty Saab was there, Dubey Saab was there. I was a novice actually. I only looked after the typing. You can understand that. So the document I was ready. So we got the immediate grant from the planning commission, something like 35 lakh. So we had a separate building for us, the whatever we wanted for 35 lakhs. Even applied mechanics department requested Professor MP Singh that you are working on air pollution, and for air pollution you need a wind tunnel. So instead of wind tunnel putting in your lab, why don't you put in my lab? So he says it's IIT, so our students can go and work there also, and you have a people. So we even had a wind tunnel in that, where the lot of things, air pollution dispersion studies were done, were studied. So the center started like that. So we had a center, and all along, if you carefully watch what I have talked only 2 people, 3 people, IMD, IIT, PK Das, MP Singh, right? So when you have to grow any activity, you don't need many people. You need only few people who can converse. The rest, like people like me or Professor Das or Professor Dubey and Mohanty, they are always there because you can say, hey, come here, join me and do this work. And then you grow, right? So the pace of research can be enhanced in this manner. This is what I have found. And if you look my one Indo-French project, the story of the Cray, I have already told you. The Cray XMP came for. Can you go down? So the 90s. So this is all the story from 80s and all that. In 90s, that NIC Cray was. So after Mrs. Gandhi talked to Reagan, and then Reagan started STI program, and then the India government, Mrs. Gandhi was not there. So, but the parleys continued. The NIC was made responsible for the evaluation, and a team was there, me, Dr. V.K. Mishra and R.K. Datta. We 3 went to US and benchmark. The point was, Rajiv Gandhi Saab went to Japan. He went to Japan, and Japanese were very keen to put their system in India. Dr. Sheshgiri, who gave me free time, to all IIT people, Dr. K.J. Ramesh has completed his thesis there. So you can ask how fond memories we have of NIC. So Sheshgiri Saab said, your benchmark, can it test, verify, can it evaluate somebody's IO? I said, sir, my model only tests the IO. Rest computing is done. He says, okay, I need that. So I gave him my model. And that model was already there with the Japanese because NEC SX6 was there. NEC's SX6 was there. So their computing was very fast, but the IO was so bad. And can you imagine that same NEC developed to that extent their IO that after the Cray, the NEC, after the Cray, it came the Japanese computer, and that was NEC. I don't know what is SX. This thing went to the ECMW. So the kind of work which we do, maybe you can think that these days it doesn't matter, but what we may say that what we do at that moment actually has a future for further, solving of the problem. This is what I have learned in the working in the IIT, on the problems of meteorology. Can you go down, please? So this is a kind of picture. We had a project under the SEFIPRA, which is in the India Habitat Center. So I put a proposal with Professor Sadhoni, and he says, we can't have development. So you have to think of a research, science problem. Science problem was interannual variations of monsoon. Means there are within the season, and then you have year to year. So for me, the good part was 87 and 88, they were the contrast monsoon years, and the data were available. Shamurthy also worked on it a lot. The ECMWF also scientists, they worked there. So there was some guidance, and it was almost put as a textbook truth that SST plays the key, right? But I thought that me and my colleague, Dr. Abel Lothroth, we discussed this problem and then discussed with Sadhoni. Dr. Sadhoni said, yeah, what you say makes sense because monsoon means clouds and clouds have modulating power. So what you say, but how to verify it? So to this thing skip C1 clouds, they were just collected for some years. 82 started, so they just started coming, and my one colleague in LMD, she was working day and night. She says, I have, means for one season from this month, she calculated that for every month there is 11 magnetic tapes. So can you believe I just used to put the tape, read it, extract this thing, and make my picture and data. So for continuous 3 months, I was just extracting. So the clouds I extracted and did 2 simulation. I did a large number, but the 2 I am putting. One was with, the CMS cloud modeled in the model, and in 88 and 87. So if you do, 88 was a good monsoon year, 87 was a bad monsoon year. So if you do the difference, you can see the positive, right? So the monsoon current is positive because 87 is a bad year. But when I put the escape clouds, you can see that 87 minus 88, if I put the prescribe the clouds, the flow is actually opposite, right? And if you carefully see, there is an inflow here, there is an inflow here, there is a very slight outflow on this side. And you can easily say that all this is happening because there is a heat source. So the Gill solution just in 82, they were available, which I set for a night and solved all this because it's all mathematics. So this solution was clear to me. So immediately I found that after doing 50-day simulations, rather 60-day simulation, 10-day we don't count. So, and I get this mean picture. It's very astonishing actually. So how accurate are the simple exact solutions of monsoon, right? So it's basically says that this heat source, right, in 87 is stronger than this. So this is what the meaning is. So So this was a very learning experience for me. And we also, another, cooperation you can see that when we are talking. So Indo-France Center told us that you can have some seminar also, because on monsoon we don't have anything. So why don't you arrange a seminar? So I discussed to Professor Robert Savorni, and he said, okay, we can have a monsoon seminar. So we had this seminar in March 1996. At that time, the megatrophic plan was actually presented here. We invited Professor Narasimha, but Narasimha was abroad, so he could not attend. But it so happened that after some years, Professor Sadoni used to come as a member of the Indo-France Center. So he was, he has to visit various institutes. So he has to go to IIT Bangalore also. So he made a point that I'll meet Professor Rudam Narasimha. And Rudam Narasimha, he said, oh, megatropic is the word which will be both India and France. They agreed. And immediately said, okay, this I will, when our next meeting is there, because he was the member of the Space Commission. So in the commission, I'll put in, it will be done. So the megatropic approval came, and you can see that although we are having a monsoons, this thing, but a person from CNES and LMD, they joined hands and they say we can have a, so the megatropic, actually the satellite is very different. All the satellites we have polar orbiting. Actually, this rotates in a very wobble manner, and that trajectory was designed by Sadoni. He was the director of IMD. So he designed that whole trajectory of orbit of megatropic, which was very special. The three sensors, one was developed in Madras and two were developed in France. They were payloads here. SEC actually took off all these things, and Pradeep Pal was the actually program director of this thing, and Professor J. Srinivasan was actually the program coordinator from India. So the thing is that though we are having a seminar, but in that seminar there are an idea of a very program where two different agencies also can work. So meteorology, don't think that it is per se to forecasting only. It is actually has it everywhere. So when we speak of monsoon, it has different meaning for for the tourist. It has different meaning for a tourist operator. It has different meaning for a politician. It has different meaning for a for the bureaucrat. For us, it means that we should give good forecast, right? So a businessman will think about differently. A cultural team will think, oh yaar, monsoon में तो मजा आ जाएगा, dance का मजा आएगा, इसका मजा आएगा. So these guys, so actually in this field, you can think of any activity, and if you have the right people, you can connect them and you can really make a difference, which has been possible with few people in mind. The another thing which I want to say, this aerosols and monsoons, after that I'll try to wrap it up. So we had a program under CEPIPRA, but I had a friend in IIT Bombay, Dr. Chandra Venkatraman. She studied at IIT Delhi and then became a professor there. So she was also keen on this. So can you raise it? So this is actually the time of INDOX. INDOX, Dr. A.P. Mitra from NPL, he was the main thing. And Dr. V. Ramanathan from San Diego, they designed, and Paul Crutzen, the Nobel laureate, these three people were actually the main architect of that. So in 2000, I started, rather 1998, I got a visiting professorship from the École Normale Supérieure, in which LMD is there. So that visiting professorship was actually very flexible to me. They say, when I asked them, they say, oh, you can have 12 visits of 1 month every year. You can have 15, 24 visits. I said, I don't want this kind. Then you have full liberty because it is from the Ministry of Foreign Affairs. Sorry, Ministry of Education from France. So there are Americans, you know, they come for 15 days, give this thing and then, but they have actually the fixed number of 1 year. So it was 1 year for me. So I told Professor Sadoni that I'll prefer 3 months or 4 months and 3 visits. He said, fine. So 4 months I had. So once I took sabbatical and I was started working on the development of this. So this was actually putting chemistry into the GCM. So I had to again brush up after 30 years or 35 years, my chemistry. The hydrolysis, everything I had to read from rate of reactions. So they were all put there. And here you see that we actually simulated the sulfate, right? Transformation of sulfur into sulfate, nitrogen compound into nitrates. They are the aerosols. So you can see the January kind of this concentration, and in July, there is a high here, right? The aerosol concentrations are high here. And you may wonder how, means I don't have tropospheric chemistry. Where is that? So there is no chance of formation of aerosol from the troposphere coming down. You can see the high here. So it is all pumped from this thing. And what is that? Pardon? So what is that pumping mechanism? You can clearly see our.
This is interaction screen. Yeah.
Can you go down? The curtains. Okay. So can you bring it down? No. I'm discussing. So this is actually because of the monsoon. The monsoon convection is so strong, it actually pumps the gases up in the atmosphere, and there the chemistry takes care, and you have in situ formation of aerosols here. So you have two highs, one because of a lot of moisture available, and surprisingly, my student, she is now professor in BHU. She was amazed at how this plume of aero pollutants is coming from China and merging with India. So our contribution is only 30%, right? And so you have this whole area is a preferred zone of aerosol formation because you have South African emissions entering into this. The Southeast Asian countries' emission is also entering into this thing. And if you have, for example, a Nino here, right, there will be downward and it will be huge, kind of factory for the aerosol production. So this was a very nice thing, and we actually published into Journal of Geophysical Research. And the thing is, they charge money, and I am a very casual person. So my student asked, they are asking $5,000. I said, right here, I am a young student, and I'm the first author, and if I get this publication, then I get a lot of appreciation. If I don't pay, then you refuse to publish. So came the reply. No, we are not refusing. We are publishing it. Don't pay anything. So she was happy that she got a award of $5,000. So paper is published. So all these things are there, and can go. So then we were ready for the kind of MOES was IMD moved from DST to MOES, and the story of moving from civil aviation to DST was some I already told, but I reserved that. So when Venkatraman was calling Das Sharma, and Das Sharma used to connect to Professor Das. So all this story was known to the IMD, staff union, because staff union knows everything. So when Professor Das became a DGM, so they say we want to, celebrate and facilitate you on becoming the DGM. So they all came here because and garlanded him this and that. So one guy, he was a very nice poet. So Professor Das is sitting, receiving the, congratulations, sir, this, that, the garlands also. One fellow said, now we have a poem on this occasion, and one line which Das used to tell me. So the Venkatraman's PA was Das, Professor PK Das, also Das, right? And then his PA was also Das. So the employee unions, that Kavi, he says, दास साहब को एक लाइन है, हम उन दासन के दास हैं जिन दासन के चरणों की तुम धूल हो. So Professor PK Das, he got so much, alarmed by that thing, that he immediately connected that Das, who is actually a clerk basically. A clerk is threatening the DGM. So he said he cannot, the IMD cannot be the part of civil aviation. So then Mrs. Gandhi, through the SAC recommendation, there was a scientific advice committee for cabinet. So through that, immediately it moved to Department of Science and Technology, and then started the STI program. And means Department of Science and Technology is a very different, it's an open forum and something like that. So after some 10 years of cooperation, I actually reserved that point for now. In 80s, when the center was formed, and Dr. Das, he was saying that there may be projects, there may not be projects. So why not IMD and IIT? It's a very special arrangement at that moment. Very special arrangement. Means my salary, half of the salary was paid by IMD. So on 50% cost sharing basis, the center at IIT Delhi was functioning, and 50% IIT was sharing the cost and 50% IMD was sharing, recurring and the salary both. And that somehow continued for 10 years or 12 years. At some point, I think there was some disconnect, and it was not handled properly because our head was PC Sinha Saab, and director was, I think head was SK Das Saab. No, not SK Das Saab, SK Dubey Saab, and our director was Raju. So somehow Dr. Raju said that the kind of conditions they are putting, that IIT should submit a project and then IMD will finance it. And whereas the agreement is that 50% cost share by IMD. So this, to me as a director, doesn't look good. And Dr. Dubey could not, save anything. So for some time, actually, we did not have. Suddenly, when Shailesh Nayak Saab came, they were saying that we should have capacity build up. So again, I'm saying how people matter, how the time matters. So again, he said, we should talk to academic institutes for finance, and capacity building should be there. We were also saying that because now our students are not coming in that, so maybe MTech students come, we can pick them. अभी आता है कुछ पूछते हैं 2 सवाल, और मतलब we are not comfortable because all people have become professors, and then they have some knowledge. Earlier there was no knowledge, but still the they desire that we will work. So students को साथ लेके चलेंगे. So we were thinking of the MTech program. So we made the MTech program, and Dr. Sati Vasu gave certain input. And then we started discussing with the IIT administration that we want to start a MTech program. Another MTech program you can start, but what is the employability of a program? People should be employed, right? So their employability is important. So first give us data, what are the institutes which can this? So I said, IMD people, they can go to IMD, they can go to this thing, that thing. No, this is not the way. Give this thing, kind of thing. By then, Yagi Saab became the DCM, and we talked to him, and he actually know IIT very well. He was part of from IIT, and he worked with Dr. Mohanty right in IIT for some years. He said, what is the other condition? He says, other condition if that, for example, we have people coming from DRDO. They come for BMTech, but they are already employed and they are coming for. So IIT also does that. All armed forces, the people they come, stay there 2 years and do their MTech and go. So that's the another model which is existing. So Tyagi Saab said, okay, 6 people I can give the grant. So 6 people. Then 1 person from Air Force, 1 person from Navy. So we have 8 people. And then for having something like this, so if this is the general, then we have the reserve category also, and ST and SC. Some, if you do the calculation, we did all the calculation. So we have a full class, no problem. So we went there in 2008, and the program started in 2008, and the MTech program started. So all that 6 scholarships for the MTech, and actually MoES gives us much more. They said, okay, we'll give you grant for this thing. IMD said we will supply the students if they are ready. So I think people go there. At least I know Rizwan did that because he's still in contact with me. Rizwan is one person whom I remember very well. And the MTech program started. So again, that the need of that time and the people at that time who can appreciate that this can be done in a different manner easily. So you have the right way to start a program. So this is how our MTech program started. And now, of course, when the MTech program started, Dr. Basu, she said, you have only for students, right? You don't have anything to give some input like distinguished professor or something like that, because that chair we have in IITs. So Dr. Dubey told me, you are the head, make a nice description, and that this distinguished chair is this, make a nice, because Dubey sir was already a director. So he said, make a nice description about, so we had Dr. Sir Gilbert Walker, MOES distinguished professorship. And then we had 3, for example, the young faculty when they come, then we have to attract, for example, a fellow can go to IIT Bhubaneswar, can go to IIT Bombay, can go to IIT Madras, right? Or to PRL, right? Means what's the attraction he has? He has his choice. So we thought that we can give him Sudhanshu, Sudhanshu Kumar Banerjee fellowship, young fellowship. So till he moves to that particular level, right, he can get that scholarship. So 10,000 rupees extra. So actually in this manner we attracted. And I tell you that this really worked because we have Dr. Day, right, Dr. Day, who works in pollution. He was actually grabbed by PRL, but it is this fellowship, because First, it is his fellowship. He can have a nice word in his biodata. That's Sudhanshu Kumar Patnaik, Sudhanshu Kumar Banerjee, Young Fellowship. So this makes a difference. And then you have 10,000 rupees. So I mean to say that the journey, and that we started with a program of cost sharing basis with IMD. Now, actually, IMD is giving us the input. That time also they were giving and monitoring me. Now they are actually sending their people to IIT for MTech or PhD or whatever it is. So the thing is that if a thing starts once, only the form changes, nothing else. We remain always together. So that is what I have realized. And during the course of this thing, I may just say that this is actually, I'm not going to discuss it. This you can read. You know, when we do a lot of things and you study so many this thing, there are certain things which people say, what is the essence you can put into something? So, for example, I used to come here for the map discussion. And I still remember there was one synoptic meteorologist, Goel Saab. He used to say, onset कैसे होगा? Onset ऐसे होगा कि ये ऐसे जाएगा. Oh, you know, the level of you know, westerlies, they go down and the easterlies go up. So जब ऊपर जाएगा, there is no friction, so you will have jets. So that wonderful description. So I thought his idea, nobody will appreciate except I can put it here. So as a southwest monsoon establishes over India, the level of westerlies go down, implying northward shift, and that of easterlies go up. As the monsoon current is lower and easterly flow attains jet speed, this is actually his this thing, right? And this is the idea which he has nurtured and advanced in the IMD, right? So I find that this is another, for example, when you hear Professor P. Koteshwaram, he will say Tibetan plateau is an elevated heat source, right? That is another thing. What elevated heat source will do? They will pack all the isobars up, so a high is created. So meteorologists will think high pressure, there is a divergence, so it will go down, right? So equator sinking, this thing, and then there is a, you know, a sympathetic northward flow which will be drifted this way, or after crossing equator, it will come back to the India. So that's the monsoon current. Now you go, can you move further? This is actually a thing which go down. Yeah, this is actually something which I observed. For example, heat low. Heat low in IMD is a word with the moment you go to map discussion, at the time of monsoon, say, for example, RK Datte, heat low kahan hai bhai? Heat low dikh hi nahi raha. So same thing, you know, all this. Dr. Mukherjee, for example, he was one very old. He used to work in meteorology and oceanography. So so radiation meteorologists, what they will say, okay, actually P.K. Das Saab has worked on this problem also, heat low problem. So he actually found that there is a sinking motion in the heat low. Now sinking motion in the heat low, how it happens? Because when there is excessive heating and the column is clear, all the heat is trapped at the ground. So temperature has increased. So infrared flux goes up, right? So, and there is a reflection of the sun's, you know, radiation. So actually, it's a cooling of the column up because it doesn't receive, which is right. It cannot absorb anything, right? So there is a adiabatic sinking, right? And that's how they develop. And the heat low is actually, if you ask me, I have visualized, you can also visualize. So upper level convergence, it comes down, right? Because you are seeing. Then at the top of the boundary layer, right, it will go up because from below. So you have up current there, you have down. So you have two convergences, one at the bottom, another at the top. That's what the heat low was explained to me. And I thought that it should be put here. This is what I have done. And so long the heat low is maintained, your monsoon current will always maintain, because to actually what we can say, replenish the deficit of the energy, you have to have a release of energy, and that is only by the latent heat release, right? That's what Pisharati Saab used to say. कि वो heat pump hai. So these are the things which I have put. Then one more, please. You know, I am a fluid dynamics person, and geophysical fluid dynamics is very dear to me, right? So Pedlowski's book, I have read it page by page. So there is a geofluid dynamics, this thing, and I tell you that they have a very different thing. So for meteorologists, monsoon starts from the top, right? They say, okay, because there is a equator, there is a heating on the landmass, so there is a northward flow, and northward flow starts from the ocean, Indian Ocean. So as it moves northward, there is a left drift because the Ekman drift is left, and so it westward it moves, and it moves towards the Somali coast. Then it crosses equator. Then the Ekman drift is on the right, so it will start moving eastward, 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 and it will hit this thing. And once it goes, they say thermal wind will back the wind on the top, right? And then that's how the circle of or the monsoon cell is. So this is what the 4 definitions I thought as a part of my learning, right? You should also learn. And I close my lecture here with the acknowledgements. First of all, to Mahapatra Sahab, I can only say you, sir, in this very room, I cannot express my happiness more than saying that in this very room, I saw the development of my career in just one word. You have to work on a variable grid model. And around that, I have learned so much, right? So modeling is one activity which teaches you many things. Data preparation, interpolation, graphics. For example, if you ask Dr. Ramesh, he actually helped me draw the isobars and these ISO tags with hand, because Professor Singh said, do an experiment. And as a mathematician, I said, okay, give me 79 data. I put that onto FGGE, a small slice, and did the calculation. And we got from the same model, we got the monsoon onset of 79, right? So data synthesis, I was doing that. Of course, we wrote a very small paper in a conference, but the kind of thing that we did that. So thank you so much to you, sir, first of all. Then I should say that I have already talked so much about my mentors, Professor P.K. Das, MP Singh, Robert Sadhoni, and also my apology that I have not done anything new. Honestly, I tell you, I feel very bit embarrassed, but say that my 50 years of scientific and technical cooperation between India and France, and Jagi Saab helped me to get this thing. So, but next Saab is sitting here. He actually provided me this thing. After retirement, I tell you honestly, I have not opened any book, honestly. But your Anoop's mail I got 15 days ago. So for 15 days, I have been working kya ho sakta hai. And whatever I have missed lot many things. But I have not missed one thing, is feeling grateful to IMD. I will never miss. And so I have only one line. What could be the finest moment for me to enjoy other than the happiness of sharing my contribution, thoughts, and some good reminiscences with you today? Thank you so much.
We will take some questions.
Yeah. Okay.
Thank you.
Thank you, sir.
Thank you. So thank you very much, sir. It was an excellent story of the development of the country, especially with respect to the monsoon dynamics. There will be many questions and curiosity in the minds of the people participating in this program. Now the floor is open for the questions and comments.
So I see at least my 3 students here.
Yes. Thank you, sir, for the very nice lecture. With your lecture, actually, I was imagining that what was the era behind, like from 1 MB to 3 MB. Now we are talking about the server petaflop, and and at that time, the knowledge was in the mind of mathematicians who were able to transform mathematics into the computing platform. Now that transformation now actually it has a quite a large change. You have shown us some of the figure which how the monsoon lines can be described in terms of the mathematical functions. Now we have that information, we have a lot of data. Now today that transformation, what work you have done and contributed, you have shown us all the information about the development of the meteorology. Now that has been into the era where we have a lot of data. Now we know this is the monsoon. All those things has been applied. The current challenges now, if we look from here to future, so we are seeing that what is the next step for our development? What is that push and collaboration that we need to develop?
Yeah, I can tell you that. For example, when we started the CAS, there were only 3 thrust areas. One was meteorology, another was meteorology with emphasis on NWP, the oceanography with emphasis on storm surge, because storm surges were, sir knows very well. Then air pollution, because nobody was talking about air pollution. So air pollution was there. Now we have climate science as a thrust area in CAS. So, but the climate science per se is not an individual subject, right? Meteorology you can do individually. But climate science actually requires, for example, my last that I could only integrate in a limited time the air pollutants, the aerosols, right? I gave the fixed oceans surface. So if you have these coupled models, then only you can have this thing. But now climate predictions, right? We had the era of weather prediction. Now climate prediction. And for example, if you go and ask to ISRO, they will say, I want space predictions. Because they put their, they say, I want weather prediction that is there at the time of, rocket shooting, right? But after that, I need the space predictions. So the demand is more computational. It's very, for example, the high, people have found later on, I did not emphasize much at that point, but it's actually the aerosol layer, upper troposphere, they describe by different name. I didn't find any excitement in giving that it's a high for me, but actually it is a upper troposphere aerosol layer. So likewise, I think the computing resources right at IMD you have. So the monsoon climate, for example, if you ask me, there is a saying that on the day of Janmashtami, rain to hoga hi hoga. This one word has started 5,000 years ago, right? So you can do something like that in the climate sense. What is that thing which is propagating all through, right? All through. And this is the new knowledge which one should look for. What is the persistence in climates? So, for example, synoptic meteorology, what we were doing, we were just drawing a line which you call axis. I used to call it axis drawing between this thing. So you say, okay, wave will go like this. So today is raining here, tomorrow here, tomorrow here, tomorrow here. So the depression will move like that, right? Sir will only say after crossing this, you will have stronger rain because it can do devastation, strong winds and the rain. So the thing is the persistence of a system. That's how the machine learning and AI can do some kind of thing. more and more applications. So the whole thing is we were working with application of mathematics. You should work with the application of models.
Yeah. Shravan.
Sir, thank you very much for the nice presentation and getting us to the long history of IIT Delhi and Indian Meteorological Department. You had also told us the history of the first supercomputer, how it was brought to India. So, sir, my question is, you have generated a lot of, there were some experiments, MONEX. So, what is happening to these data sets? I hope these data sets are well
So
stored.
data sets, for example, I used to use the ECMWF. ECMWF data are always available.
So ECMW, but there are some unique experiments which were being done or being carried out, right?
You know, the models have also changed.
No, not models, observations. I was also
Observations we normally did not take. We only took from IMD.
IMD. Okay.
So
Even
IMD
I-
had-
Yeah, but what's one more question, sir, regarding this is non-scientific, but so many of our staff, right, scientific assistants, meteorologists, they are MTechs. So many of them approach us for registering for a PhD. So is there any way of connection so that
request to sir and these
I
people
already
will sit
requested.
together, they will find the way. Because IMD can send the people for PhD. The only thing is that, again I quote Dr. P.K. Das, he says, my officer, if he says, I want to do PhD, then I tell him that I cannot guarantee you that you will stay here, because if I have to send you on a different regional center, you have to go because operational duties are there.
Yeah,
So it is somebody's personal this thing, but I think the administration never took R.K. Datta, for example, he did his PhD under.
So from IIT's point of view, how is that? How would that?
They require a certain number of credits which you can do early in the morning.
And for us to register as a PhD guide?
The PhD guide, you have to talk to the guide there. Then you have to talk to the guide here.
No, myself want to be as a PhD guide to a student.
Yeah, I'm telling you, find a guide here. That's what IIT works. It will be a part-time. It will not be that you will be sitting there in IIT.
Okay.
You will be doing your job, but have a guide here and a guide in IIT. That's how it works. So
Co-guide.
the modality is clear-cut.
Yeah. Thank you, sir.
Co-guide has to be there.
And IMD encourages the people to go for PhD programs in IIT Delhi, even everywhere, not only IIT Delhi, all IITs.
You can go to
And
Bangalore
many
also.
people have done PhDs in IIT Delhi also. As sir was telling, there are some students here present who have done PhD in IIT.
My own student.
And people
Bhargava.
working in PhD, if you take example, I am a student who was working in IIT Delhi. Okay. But being registered somewhere else, but I was working there. There are many who have worked in IIT Delhi. And for your information, 3 DGs have come out from IIT Delhi.
Ramesh sir,
Thank you, sir, myself.
अच्छा अभी हाँ अभी तो थे मोती साहब के साथ.
Yes. Yes, please.
Well, thank you so much, sir, for giving such an informative lecture. Sir, I have a question, sir. Actually, from your experiment, whatever in paper you have showed, so in that you have mentioned that 70% of the aerosol formation
Come nearer to mic.
So the online participant.
Yes. So actually, you have mentioned that 70% of the aerosol formation over Indian Ocean is due to the transportation of pollutants from China. So
No, 40%.
40%. So, sir, is
40%
it
from our maximum, so almost
Okay.
70%
Okay,
total
sir.
if you
Okay,
join
sir.
together.
So, sir, is it for particular month or throughout the year, sir? That thing?
No, the month was there. Na?
July, sir.
No, the other month, winter months.
Winter month.
Yeah.
So, sir, that is for the that is study period for how long that study has been done? Sir?
Maybe
For the
Indo-X,
period.
Yeah, that was Indo-X data available there.
Okay,
You can look at that.
Okay,
And the only thing is that I can tell you that here we speak so much of pollution, but we are not speaking pollution from outside India. You know, what happens, the outside pollution actually gives a mean level up. Even Parali is actually, if you ask me, I'm not against Parali. Parali is just a momentary activity, but it gives a peak. And the activists, sir, what happened? Look at the peak. But that peak is available only for the moment. But since they are for a particular 15 days period or 10-day period, it will be actually a peak and they say Delhi is dead. But the idea was showing that there is a lot of pollution coming from midlets.
Okay, so that is the general trend, sir.
So
It
background is
happens.
up and
Yes,
then
sir.
you have these peaks.
Okay, sir. Yes, sir. Thank
So,
you.
so my point is that don't blame India, blame the other side, neighbors also.
Yeah.
Okay, thank you so much, sir.
Okay. I think online, Dr. Anup. Dr. Anand.
Sir, I have a question. Can you hear me?
Yeah, I can hear you.
Madhulata from
Yes,
IMD.
please.
Yeah, this is Madhulata from IMD New Delhi. It's very interesting talk on monsoon research. Particularly, you covered the modeling perspective, both the international and national. Sir, in your presentation, you showed a lot of components like synoptic meteorology, fluid dynamics, aerosol, and all. With a lot of development both in modeling and observation. Still, if you see the extreme rainfall episodes associated with the monsoon are still not at all, still improvement is needed. So according to your expertise, which component?
Yeah, convection.
Convection.
Convection, yeah. For example, these days we have the mass flux schemes, which actually, in a very simple manner, model the cumulus convection, right? And the deeper the formation, like cumulonimbus, deeper the formation, larger is the cloud. And what I say that pollutants can actually grow the clouds very high, and larger the higher means more of the water there and the possibility of a very intense rain. So the impact is very high.
Sir, in this direction, any development work is going on in IITs for Indian region to develop convection for Indian?
My apology. After 10 years, I have not opened anything, and I have hardly visited the IIT Delhi CAS. But you can talk to people there, and the young guys are there, 2 or 3. I have yet to meet them, and they can guide you very well. But basically, I think there is a very wonderful person in IIT Bhubaneswar, young fellow who was, I don't remember his Patnaik or something like that. He worked with Professor T.N. Krishnamurthy also. His Patnaik?
Sandeep Patnaik.
Sandeep Patnaik.
Sandeep Patnaik, yeah, I think Sandeep is the name. Sandeep Patnaik can help you better because he understands convection better than me.
You work with TNQ.
Okay, sir. Thank you. Thank you very much.
Sir, may I?
Yes, Dr. Anand.
Yes, sir. Thank you very much, sir. Anyhow, sir, my personal gratitude, sir. I learned a lot of things when I was in IIT Delhi from you. So that's why I now dare to put a question to you, sir. Today, when we fail to predict through dynamical model the monsoon, we actually blame, sir, model, but not the initial condition what we provide to the model. Sir, whether actually we should be very much focused now on coupled data assimilation or model development, sir. Which one?
Anand, the initial condition problem is always there, but initial condition, who prepares, it depends on him also. I give you an example. My initial conditions were prepared by some other person and he made a mistake. Instead of moisture, he put the variable for geopotential, and geopotential height is so big and moisture cannot be that big. But model did not fear it. The moment there was a kind of instability, it cleared it. So if you ask me, initial condition should be the person who is doing the experiments, right? He is the best person who will be most careful. Secondly, the interpolation schemes are available there, and you are the person who will choose that. Earlier, we used to speak of lot many kinds of objective analysis, this thing. These days, the network has become so fine that practically you have to, for example, rainfall is so much of, but that level of grid, if it's not there in the model, and you have to prescribe based on that rainfall, the heating into the model, right? For example, your cumulus convection, you say that I can give an initial heating to the convection, right, based on the rainfall. But if that is not calculated by you and somebody has calculated, you do not know in what terms, what is the area he has taken, how much, what is the units he has taken, for example. So I am very clear in my mind that numerical modeling, it should be very carefully done. As you say, initial conditions are very important. Prepare your initial condition. The models are almost, if you ask me today, that this model has become so sophisticated. Essentially, the model's dynamics and radiation has not changed anywhere. And these are the two solutions which are really very close to exact. Where we have the uncertainty in the cloud modeling, where we have the uncertainty in the boundary layer representation, right? Where we have uncertainty in the representation of the vegetation. Get my point? So, or the ocean temperatures, for example. Ocean temperatures also we are having at practically at 10 half a kilometer kind of grid. So they are far better than earlier. We used to have 10 degree by 10 degree SSTs. Get my point? But when you have everything, don't forget to do a sensitivity analysis. Perturb those things and see whether the model is really giving you the same thing. That's what the climate simulations people are doing. And they have to do it because of all these things.
So presently, sir, nowadays the assimilation, which is very much sophisticated 4D variational and ensemble data assimilation. So there actually whatever you mentioned, sir, we are looking into the perturbing the initial state, as well as we are giving some kind of in the ensemble, we are putting up some kind of space for the model to give the uncertainty. But problems are here still there. Even our ensemble model, when it is only atmosphere, maybe doing good, but when we are coupling it to the ocean, then it is not doing so good compared to the only atmosphere. So that means somewhere, sir, we have to develop one single coupled assimilation. So that kind of actually work is very recently only started, but nobody is giving importance, rather than we are going for AIML and other thing.
Okay, I can answer that. See, for example, how ocean gets energy from the atmosphere. So you should understand that when there is a wave on the ocean, on the crest side, there is a higher hydrostatic pressure that will give horizontal motion. You get my point? Another gust comes, it will again push the high, the former, this thing will be dissipated, it will go down. So there is a momentum transfer continuously into the ocean. And so one time it is this way, another time is this way. So the shearing motion, right, they cancel each other. But to some extent, so not all energy that is pumped in one gust goes into the ocean. It actually goes a very epsilon kind of thing. So you have to quantify that, right? If you know, there is a book by air-sea interaction, is the book, I don't remember it, the famous, actually I don't remember the name of the author, but the book is with me. And on reading that book, you will see a lot of light how the interaction of ocean and atmosphere goes.
Thank you very much, sir. Thank you very much, sir.
Thank you. Thank you.
Any other, anyone else? Yeah, Raghu, Dr. Raghu.
Thank you very much. Very good lecture, sir. So actually, we have used the variable grid in the GCMs at global scale. So that time, I think you applied Fourier filter for the eliminating the noise in the model. But nowadays, sir, many regional models also have this capability, and many people are working in the global wide for putting this variable grid concept in regional models.
Regional model, huh?
Yes, yes, sir. Especially when we are doing this stretching grid in the regional model, sir. Over the zooming area, we are getting the lot of noise because of the vertical CFL. Because here we have to use the non-hydrostatic dynamics. So that time our vertical motion is
Very high.
very high, and somewhere we are model is getting blow up. So any techniques to avoid those noises, sir?
Okay, I can easily tell you that. Apply a filter.
Yes, sir. Filter we are applying, sir. At
Apply a
present,
filter,
sir.
and then filter. For example, we have numerical filters.
Yes, yes.
You know, there are numerical filters which are analytical,
Yes, sir.
right? Means you will say that, but there is a danger. You know, that analytical function actually constrains the entire data to fall on that.
Yes, yes, sir.
Get my point? So maybe Amit Bhardwaj can help you because he was doing a lot of this thing. So it's basically SVD. You have the
Yes,
data.
yes,
I think you have done on SVD, I think. All the SVD. It's basically SVD. So from the data, you design a matrix
sir.
and you don't consider all. Reject other and keep those SVD few the part. It's you better read of Gil Strang's book is there. Gilbert Strang's book is there. I love that book because how SVD basically what happens, you have when you work with data, the matrix is not square, it is actually rectangle.
Yes, yes, sir.
But the thing is that you make A transpose and A transpose, the two things together becomes a rectangle, right?
Yes, sir.
But eigenvalues are same, but eigenfunctions are different, right? So you take the eigenfunctions, right? Eigenvalues are
Eigenvectors,
same
yes.
and eigenfunctions to filter out those things. That's what practically I have done in the
Yes, yes,
Fourier
sir.
series also,
Yes,
Fourier filtering also.
Fourier filtering, yes, sir.
Yeah. So basically, when you are working with data, work with SVD. I think he has a good thing. As a part of his PhD, he has done that. So he can help you in SVD.
Thank you very much, sir.
Just
Sir,
take instead of 5, take 20 and reject all. That's all.
Sir, actually that kind of filter works well on the high terrain, but problem actually we mostly face, we try to avoid in our domain the high terrain and we try to do that, but problem comes when it is a very strong convection within a very flat terrain, but that strong convection actually giving some a big value of W and which is actually blowing up the model. And there we face the problem, sir.
In the numerical models, for example, if you are using leapfrog, you will land into that problem immediately. So use a dissipative like Matsuno, right? Or any dissipative rectangular means what we call, yeah.
A numerical scheme we have to look into, sir.
Yeah, you have to intermittently change the numerical scheme.
Okay.
Write your own numerical scheme in Matsuno, for example. Matsuno has a inbuilt, filter which actually works on the frequency or wavelength, whatever it is. So certain wavelengths, it will just chop off. Or you can do one thing is use a dissipator like Fourier, del square, right? Instead of that, use a del 4. Then it selectively filter out the noise.
Hi. Dr. Balchandran, do you want to speak? Any comments or questions?
Mic, okay. Yeah, mute.
Sir, kindly unmute yourself, sir.
He's on long time.
First unmute. Balchandran.
Sir, you are muted. Kindly unmute yourself.
सुनाई दे रहा है कि
सुनाई दे रहा है. You are muted, Dr. Bala.
Balchandran, you please, you are muted actually. Please unmute.
Yeah, fine. Okay, Dr. Patnaik.
So, before I go for last question, first it is a very compliment actually, sir. You said one thing that after retirement you have not touched seen any book. Still, you have covered the entire thing. And one thing we must learn from the today thing that how when we miss how an idea, synoptic idea that can be explained mathematically. So actually that is the miss how model development should take place in that way. So when you just you are showing that way, actually that is the way how the model development work you have done in initial period. And for just for when we are compiling this 50 years of endology in India, we used to visit to his place. Then only I came across the name of many scientists, just like Professor N.P. Singh, all this other. I was also not knowing the contribution of these people. So actually, they miss that's a for the endolopy. All these Miss Stalwart, they have contributed a lot, and that's why now we have reached to this stage. And to the last, just a question, not a question, but from the other question actually, model development parts are one part, and now model has developed a lot actually. Now the incremental value is very difficult with respect to model development. But 20 years before, if we say, now we have improved a lot. So incremental development with respect to model improvement with respect to model development will less. So whether this endology plus AI, whether that will be a prime area at this stage, considering the very slow incremental value of model development.
Yeah, I can answer that with a practical. For example, when you look about talk about automobiles, if you see the technology of Easter years, yesterday and today, we had carburetors and that thing, and now we have electrical this thing also. But the basic thing is that the motor, the rotor is same, the wheel is same. It has to move. Same thing is models. Model development has reached to a stage, but you have to identify, as for example, I say, if you are studying, for example, summer month, and you are doing very strong computations on clouds, for example, right? As Anand was saying that my initial condition, if the initial condition always prefer, because you have tuned your parameters, right? Because a lot of people, they give a tuning parameter, right? You have tuned your parameter and it will always give you the convection. You got my point? That is where you have to be very careful. That whether the model has any kind of tuning for a particular situation. If that is there, please believe me, you will never, in my model or in the UK Met Office model, right? In my model, there is absolutely no tuning. The thing comes like this, the equation, these are the conservation principles, right? Potential vortice conservation, energy conservation, right? So I have not that for this is there. For example, in radiative process, the transmission function as has been calculated with data wise, no tuning, right? You say, okay, I just what I say, average it and put it there. That is not done. If the line is there, there is a line there. You can do line by line. If you are doing line by line or band by band, it should be band by band. Cannot be line by line. So this is what I say. So please look at your model. If there is any kind of tuning, particularly in the convection. Convection has people actually when I speak of core model is the best example where a lot of tuning has been done because there were two parameters. People have done, I think, a number of this.
Yes,
right. We had only one idea in the core model: low level convergence, right, and release of latent heat. That's all. This is the connection we have used in our this year. For example, when there was moist convection of Manabe, which is very rarely used, it was as such.
Yeah.
Right? Manabe's moist convection was as such. No tempering with that. So please, whenever you, particularly with convection and boundary layer parameterization, actually, I may again share that we had a very ambitious program of model development from MoES, but sir, because of my personal problem, I could not participate to the extent. My wife was not keeping well. Anyway, today everything is okay. I can say that. But that time I did not find, and I thought that I should spend my quality time with the person who is surviving. So that was another story. But I designed a convection scheme which was mass flux, and in the mass flux schemes you can believe, because the entrainment and detrainment parameters, they are the only thing, right? So entrainment has been, for example, G.I. Taylor, he gave it is 0.2 of that area. So it is 0.2. Or somebody says, okay, 0.2 divided by R, radius bhi matter karta hai. Okay. So I can only tell that if you are into model, look first the tuning, because a lot of tuning has gone into that. And I think you can give these problems to people like in IIT. I think my student is there, sir. Sarvesh Dubey. He is good at looking at models very nicely. For example, when you ask him to compute the divergence, I have used the 2 bars. He will use like this. Everywhere he will say which side is the outward normal. You get my point? So actually his question has reminded me of one very, very beautiful instance which happened something like 20 years ago or 25 years ago in ECMWF, sir. They were trying all hard. Their I think their confidence level or the reliability level reached to as high as 94. And they wanted to increase somehow to 95, 97, 98, because their aim was hail forecasting. And hail forecasting was actually from one street to another. At this street, the hail will occur at this time. And that hailstorm forecasting was to be done a day before or 36 hours. So by chance, one French mathematician or young fellow from École Polytechnique, they are mix of engineer and mathematicians. So he went there and they gave him the model. He looked at every process just like this. And you know how much improvement he brought into that entire, every scheme? 10%, 10%, 10%. Can anybody answer me what would be the cumulative effect of that?
50%.
10%. 10%. This is model. So yeah, you should not feel कि मैंने 20% कर दिया है, अब मेरे को 20%, वो शायद 2% हो. So my experience is that, for example, finite element method, if you are doing the again telling the Anand this thing, if you want to have very fine initial condition, you can as well utilize your finite element interpolations. So you can have triangular grids, and every side you have a different this thing. And writing a finite element interpolation scheme is no problem. Another thing is you have to interpolate the orography. And in orography, there are n number of interpolations. You have to take. So as far as I know, the LMD Z model, for example, LMD Z model, the person who has put the orography in the ECMWF, they are exactly safe because the same person has done the work. So if you look at the orography representation in the ECMWF model or LMD model, that is one and same. And it's a very elaborate scheme because they look at the slope, right, valleys, and then peaks, right? They are all identified. So this is what I can say.
Thank you, sir, for very excellent interactions, and I am sure all of us have learned a lot, and your knowledge will be utilized by each and everyone present here, online or offline, and we'll carry forward your philosophy in this field, and certainly will improve our understanding, modeling, and forecasting process. So I will request now Dr. Soni. Yeah,
Thank you, sir, for very insightful talk. Now, I would request our Director General of Meteorology to kindly felicitate Professor O.P. Sharma on behalf of IMD.
Again, I say I have no words of gratitude to express. Thank you, sir. Such a memorable thing, sir. Thank you, sir. Thank you, sir. My gratitude to IMD and to you personally.
And I have the honor to present the vote of thanks on this occasion of sixth lecture of 150 years of IMD. On behalf of IMD and on my own behalf, I express my deep gratitude and thank Professor O.P. Sharma for kindly sparing time to deliver the very insightful lecture and giving us historical perspectives of meteorology. I also thank our Director General of Meteorology for sparing time with us. Actually, he is the inspiration behind all the activities of 150 years. I also thank all the officers, scientists from various institutions, universities for joining us on this occasion of 150 years celebration. So thank you all, and thank you, sir.
I have only one word to say, that as I used to feel very offended when somebody used to say against IMD or IIT, feel yourself also that, sir was there when the first inauguration. One journalist, I was talking to Soni Saab.
Yes,
one journalist, he was talking crap actually. And I had to tell him that he was telling as if nobody knows monsoon here, except him. And I had to tell him that add one line, because we understand monsoon, we can think of climate change and climate predictions.
We remember, sir. Yes,
Yeah.
you interfered.
So I have taken, this is not the one occasion, sir, several occasions, right? So if you defend yourself, my wife's brother, Professor M.M. Sharma, he says, if you can't defend your department, nobody will defend. So the thing is, you should have that kind of spirit. I have never cowed down. I was never cowed down by any person when they criticize my organization for whom I have worked so long. Or for example, IMD, I have grew from the inspiration of IMD. Thank you so much. This is a very great souvenir for me for life, rather. Whatever the years I have behind. Thank you so much. Thank you, sir.